KIT's College of Engineering, Kolhapur. We are here to discuss on the course Advanced Design of Concrete Structure. First, we discuss the broader objectives of the course. First objective, identify the provisions made in IS 456-2000, IS 3370-1984 and IS 1346. Second objective, develop the concept of inline theory. And third, analysis and design of different RCC structural elements, water tanks and retaining walls. So this is our unit number 1, flat slab. Lesson number 4, design procedure of exterior panel or external panel of flat slab. Now objective related to that lesson is analysis and design the RCC structural elements such as flat slab. Up till we discuss the introduction, advantages, disadvantages of the flat slab, then method of analysis, that is direct analysis method and equivalent frame method. Next is design procedure of interior panels of flat slab. Now in this lesson we are discussing the design procedure of exterior panel of the flat slab. So we will see the procedure step by step. First step, always write the given data in the problem, such as longer span L1, shorter span L2, grade of concrete, grade of steel, loading on the slab, column height, column size, etc., etc., etc. Whatever the data is given in the problem or statement, you want to write that given data. Second thing, calculate the width of column strips and width of middle strips. Now first 2-3 steps are same as per the design procedure of internal panel, but then also we will discuss it. So width of column strip along longer direction is equal to LCX is equal to 0.25 to 0.50 L2. So the ratio is, or the factor is what, 0.25 to 0.50. You can choose any value in between 0.25 to 0.50. Second, calculate the column strip along shorter direction LCY. The formula is same, 0.25 to 0.50 into L1. But what is the condition? LCY should not be less than or should be less than or equal to LCX. Then after finalizing the values of LCY and LCX, calculate the width of middle strips and width of middle strip in longer direction and shorter direction. Next step is calculate the effective depth of the flat slab. Now again, as we discussed, there are two types of slab. First is slab with drop and second case is slab without drop. So if the slab with drop is provided, then D provided is equal to L1 upon 40 if the mild steel is used, and D provided is equal to L2 upon 32 if higher grade steel is provided. Now then calculate the overall depth of the slab as we discussed in the last lecture. D provided plus effective depth plus depth of the drop. Second condition or second case is flat slab without drop. If the flat slab is provided without drops, then you want to reduce the factor by 10%. So formula is D provided is equal to L1 upon 40 into 9.9, that is only 90% value is considered. And if higher grade steel is provided, then L1 upon 32 into 0.9. Then calculate overall depth. D is equal to D provided plus effective cover. After this, you want to calculate the total load acting on the slab. The steps are same. Self weight of slab is equal to D, that is overall depth of slab, into density of concrete. If not given, assume 25 kilonewton per meter cube. Then lie load, finished load. If not given, then calculate as per IS 875 part 2. Then calculate the total load WD, make it factored by multiplication factor 1.5, that is Wn, and then calculate the total load on the slab. W naught is equal to Wn into L1 into L2. The W naught is nothing but the total load acting on the slab. Then calculate the moments, moment along L1 direction and moment along L2 direction. If the slab is square slab, you just calculate the moment in any one direction and repeat that same moment in the another direction. But if the slab is rectangular slab, you want to calculate both moments in L1 direction as well as in L2 direction. The formula is moment is equal to total load on the slab multiplied by span upon 8, WL by 8. If your direction is L1, then W naught into L1 upon 8. If the direction is L2, then W naught into L2